Okay, welcome back. Today I'll be going through the Pei Chun Public School paper for P4. This is a term 3 weighted assessment. This paper is set in 2022. Okay, so most of the questions revolve around light and heat. Okay, so which of the following are not source of light? Okay, so let's identify which one is the source of light first. Okay, the source of light will be your campfire and star. They are definitely a source of light. Okay, mirror is not a source of light together with your diamond. Okay, because they are reflective object. Okay, it means they reflect lights very well. Okay, but reflective object are not source of light. Okay, so the answer will be both mirror and diamond. So the answer will be number 4. Okay. So over here, some ice cube were added to the glass of hot tea. So the ice cube is at a very low temperature. Let's take it as it's at 0 degrees. The hot tea probably is about at 90 degrees Celsius, very hot. So what will happen to the ice cube and the hot tea? So you throw in the ice cube. After a while, you will have realized that ice cube has melt. So there will be a change of state. Okay, because the ice cube melt. So 3 and 4 is wrong, so left with 1 and 2. The ice cube actually gain heat from the hot tea, while the hot tea lose heat to the ice cube, so it will become cooler. So that's number 2. Okay, let's move on to this part. Okay, so in this question, study the diagram below. The boy can see the ball in the presence of light. So which of the following shows correctly the path of light that's make it possible for the boy to see the ball? So the path of light always flow through in this manner. So the light emit out from the torch will hit the ball. That's the ray diagram, and then from there it will go back into the boy's eyes. So it will always be torch, or rather light source, to the object itself and to the boy's eyes. So over here, it should be number 1. Okay, torch, ball, boy. Okay, object X and Y are placed touching each other. Heat flow from X to Y. So the heat flow in this way. Okay, so only explanation is that this is a higher temperature, then this is a lower temperature. Okay, heat always flow from a higher temperature to lower temperature. That's how heat flow. So that will be number 4. Okay, let's move on to the next question. So mainly lower a flask of colored water into a basin of cold water. Okay, so let's take a look at this diagram. So we have colored water submerged inside cold water, and there is some water that reach at this level. This is the level or rather water level of the colored water. Okay. After a while, she observed a change in water level. So this change can be increase or decrease. The water level can increase or decrease. So which of the following correctly describe the changes in the mass and the volume? Okay, so when you put the colored water into the cold water, right, we're going to assume some number. Let's assume that the cold water is probably about 4 degrees. So very cold, taken out from the refrigerator. The colored water, let's take it as is probably at room temperature, 22 or 25 degrees Celsius. Okay, so heat always flow from higher to lower. Okay, so over here, the higher temperature is the colored water. It flows through the cold water. So over here, you can see that the colored water will probably have loose heat. Okay, lose heat to the cold water because the cold water gain heat from the colored water. Okay, the cold water lose heat too. Cold water gain heat from the colored water. So we are talking about the colored water, so the focus is over here. This is the focus. So when an object will lose heat, it will start to contract. Okay, when a contraction happen, there's two usually the two concepts that will be tested, it will be volume. Volume will decrease, mass will remain the same. Why mass will remain the same is because we did not add any colored water into the flask. We did not add any, so no change, either 3 or 4. Volume decrease, so answer number 3. Okay, so let's move. That will be the end of your MCQ. We will now move on to the open-ended section. So there will be 4 questions. So first question is on light. Okay, so over here we have a torchlight and we have a card with a square hole. That means over here, this area over here, this is actually a cutout. That means light can pass through here. Okay, then they ask you what will Max see on the screen. Okay, so over here the main assumption is that both objects are transparent. Okay, so over here what happened is that we will have on the screen we will see the black color shadow of a square. Inside will be empty. This is what we're going to see first from the first object. Okay, but the second object, since it's further away from the light source, this is further away from the light source. Let me use blue color, further away. So the shadow will be much more smaller. So over here, this one, so it will look something like this. So the red color one will be the nearer object. Okay, when the object is nearer to light source, it will block more light. Okay, it will block more light, therefore the shadow will be larger. Okay, likewise for the object that is further away from the light source. So over here the answers will be this. Answer will be this. That's what we're going to look on the screen. So two property of light causes shadow to be formed. One of them is light travel in a straight line. The other property is light can be blocked by an opaque object. So I'll write this down. Okay, a shadow is formed when light is blocked by an object, an opaque object. Okay, so this will be 1 mark. Okay, so over here Max removed the card with a square hole. He moved the metal object further away from the screen. So further away from the screen, it means that it is nearer to the light source. Okay, so distance between metal object and the screen, and he recorded the height of the shadow form. So based on this information, what is the relationship between the distance between the metal object and the screen and the height of the shadow form? So over here, this is actually the cost. Okay, this is actually the cost, or sometimes what you call your change variable. This is actually your result or the effect of it from moving the object further away from the screen. Okay, and this will be your measured variable. These are terms that we use interchangeably in a science experiment. So basically it's a relationship. So you take a look, as a number increases 4, 6 to 8, that means when it's getting further away, right, the height of the shadow actually increases. So both of them shows increasing relationship. Okay, so this is how we can write this. So usually we will just write down the cost first. So you can say as the distance between and the screen increases, the height of the shadow formed on the screen increases. Okay, so the main focus is this part, increase, and are you able to get it from the table over here? Okay, so this will be the main portion, so this will be 1 mark. Okay, so next up, 7. Xavier conduct experiment using a setup shown below in a dark room. He wanted to find out the amount of light that can pass through 3 different materials. Okay, so the amount of light detected by the light sensor when no material was placed was 5,000. He placed the material to be tested one at a time in front. Okay, so at first was 5,000 when no material was placed. So no material, 5,000. Okay, then when you put A, B, and C, there is some reading. Okay, so which material, okay, should Xavier use to make the curtain to keep his dark room as dark as possible? So you want to make keep your dark room as dark as possible, right? You will always choose an object that blocks the most light. Okay, so that having said, you should choose a material which blocks the most light. So when it blocks the most light, you will have the lowest amount of light detected by the sensor. Okay, because when the light comes through here, right, most of it is being blocked. So over here, nothing is being recorded at the sensor, so it remains 0. So over here, we should actually choose material A. Okay, so now we're going to try to answer this question. So I'll make a choice. Material A. I'll quote evidence. Okay, the evidence, I'll use the table. So I'll say the amount of light recorded by the light sensor is the lowest or is at 0. So A is opaque and will block the most amount of light in his bedroom. Okay, so the key portion over here is making a choice. Tell me that it's lowest or it is 0. So it is make the relationship that is opaque and it will block the most light in his bedroom, keeping his bedroom as dark as possible. That's trying to answer back to the questions over here. So which of the following material could C be? Okay, C, which is the one that have the most amount of light detected. So from here, right, we will never choose most amount of light detected, right? So out of here, right, we will never choose wood, we will never choose ceramic, because they are generally opaque object. Okay, so the amount of light detected will be 0. So over here, we will choose glass. Glass will be the correct answer. Okay, so okay, Mr. Sammy placed a cup of cold water on a table in a room. So we have a cold water placed on the table. Now we need to name the instrument that can be used to measure the temperature of the cold water. So this instrument will be thermometer. Okay, thermometer. So thermometer. Okay, this word has 3 4 syllables, so some of you may find it hard to spell, so you can break this up. You need to remember this. Okay, this or at least you need to remember how to spell it. So explain why the temperature of the cold water increase after some time. So when the temperature of an object increase, right? Temperature increase, it shows that the object, or rather the ice water, must have gained heat. So now, where did it gain heat from? It is important for you to take note or say where it gained heat from. So the object that we're interested in is the cold water, or that is being stated over here, cold water. So it actually, since it's placed in a room, right, we can use temperature. Some of you may assume temperature as a number in this scenario, so it's things will be more easy for you. So cold water maybe about 4 degrees, room about 25 degrees. So in the room, right, you will have air around it, and this air is at 25. So definitely the cold water will gain heat from the surrounding air. So there's a way to write it. Okay, normally we will write down the object and the second object. Sometimes this second object may be visible or may not be visible to you, and we will write down the gain heat or lose heat process, depending is it temperature increase or decrease. So this part over here is a key. Okay, this will be your part B answer. Okay, over here. Okay, so let's move on to the third last question. So Perrin has 2 basins of hot water as shown in the diagram. So we have 200 ml 90 degrees, 200 ml 70 degrees. It seems that the volume are the same. The only thing that is different is temperature different. So keep that in mind. So temperature is different. Explain why the water in basin A has more heat than the water in basin B. Okay, so heat over here, right, depend on 2 things. Number 1 will be your mass. Okay, in this case will be the mass of the water. Okay, so although I write volume here, right, but we can consider it as the mass of the water. Number 2 will be the temperature. Okay, so if you have more mass, you have more heat. If you have a higher temperature, you have more heat. But temperature alone is not a measurement of heat. Okay, we have to look at things in totality. That means you have to look at the mass as well as the temperature. Since the volume, or rather the mass, are the same, so we can ignore this part. We can solely look at the temperature number alone. Okay, so over here it is clear to us that basin A has a higher temperature, so basin A, or rather the water in basin A, not basin A, is the water inside basin A. So there's a difference. If you say basin A, you're talking about this basin. Okay, it's not about the basin, it's about the water inside the basin having more heat. So we need to be careful in terms of how we phrase things or how we make reference of things, and as well as don't use it, okay, when you're answering this kind of question, because I don't know what does your it refers to. I don't know. I have to guess. When I have to guess, then I will penalize you already. Okay, so over here I'll write this down. Okay, water in basin A has a higher temperature than water in basin B. Okay, this will be the key explanation. Higher temperature, water in basin A versus water in basin B. The water, this word, it is important for you to mention which basin you're talking about as well. Make reference to the object that you're talking about. Okay, so let me put down make reference. Okay, key point, make reference to the object. Okay, Corinne placed a dented plastic ball in a basin A. The ball had air in it. Okay, so they tell you a clue. Air is inside the ball. So the dented plastic ball could return to its original shape when it placed inside the hot water. It's not could not return. It's could return. So you have a hot water. Okay, let me draw this out. hot water. Okay, the air inside over here, let's take it as is a maybe at room temperature 25 degree. The hot water, let's take it as 90 degree. Heat always flow from a higher to lower temperature, so the heat will flow into the air inside the ping pong ball. So it will be that the air inside the ping pong ball or the air inside the ball would have gained heat from somewhere, right? In this case, it will be gaining heat from the hot water. The clue has been given to you. Okay, gain heat from the hot water. And when you gain heat from the hot water, the air inside. Do you realize this part? The air actually expanded, cause the ball to return back its original shape because the volume increased back. So the air inside expanded. Okay, so the key portion is this two part over here. The gain heat from where, and the air inside the ball. It's not the ball, it's rather the air inside the ball. It must be stated. Okay, expanded. Okay, so I'll write down in full. Okay, so I'll write down the air inside the ball gain heat from the hot water and expanded and push the ball back to its original shape. Okay, so whenever you are last but not least, there are some notes for you. Okay, when you are writing gain heat or lose heat, right? So let's say you have an object, you write gain heat from. You will always want to indicate the source, or rather the heat source itself. Okay, so it's always gain heat. The preposition that we will want to use will be gain heat from. And for lose heat, let's say you want to talk about an object that lose heat. In this case, will be the hot water. Hot water lose heat to another object. Okay, hot water lose heat to the air inside the ping pong ball. Okay, so we have to make reference, or at least make reference to the object. Make reference to the object. Okay, so in this case, lose heat will always come with to. Gain heat will always come with from. Okay, so that will be the end of my walkthrough for this paper. You can pause between each section to look at how to answer the question correctly. Last but not least, I'll just highlight the most important words in this question. The air inside the ball. Okay, I'll highlight the object first. Gain heat, the air inside the ball versus hot water. So gain heat from expanded. Okay, so that'll be all. Okay, thank you.